All right, so in this video we're talking about the end behavior of polynomial functions. Now, the polynomial functions are going to take care of linear, quadratic, cubic, a lot of our function types that we're going to talk about. So when I talk about the end behavior, we're talking about what does the graph do, or in particular the y values do, as we go either right on the graph or left on the graph. So the end behavior of a function's graph is the behavior of the graph as x approaches positive infinity. In other words, we're going to the right. Or negative infinity, we're going to the left. The expression x arrow positive infinity is read as x approaches positive infinity. So in example 10, we're talking about the end behavior of two linear functions. Let's talk about the function on the left. Before we get started though, just remember that f of x is your y values. So we're looking at what the graph does with the y values as we're going to the right of the graph and as we're going to the left of the graph. And there's a fly that's going around and bothering me, so if I spaz out, you know why. Alright, so here the y values are going to positive infinity, or they're going up as we go to the right of the graph. So as we keep going to the right, the y values are going to keep increasing. That's the end behavior. Also, as the y values are decreasing as we go to the left of the graph. So the farther left we go, the y values are going to keep going down and down and down. In this other picture, same idea, still a linear function. As the y values are going up, that happens as we go to the left side of the graph. Here, the y values are going down toward negative infinity as we're going to the right side of the graph, to positive infinity. So as x keeps going farther and farther to the right, the y values keep falling down. In example 11, we're doing the same idea, talking about end behavior, but with now quadratic functions. So here, this first quadratic function, as x is approaching negative infinity, so we're going farther to the left, the y values keep increasing. They're going higher and higher. As x is going to the right, farther and farther, the y values keep increasing. So that's what we're just saying. So obviously we see that in the picture, but now we're just describing that with mathematical symbols. And same idea here. As x is approaching negative infinity, we can see very clearly that the y values are falling for the graph. As x is approaching positive infinity, we can see very clearly that the y values, our f of x, is approaching negative infinity. It keeps going down no matter what we do. Now we have some rules. This is for any general polynomial function, and we're only talking about polynomials in this video. Okay? Polynomial is a type of function. I need to know two things to use my four different rules. I need to know the leading coefficient, that's going to be a number, so a sub n, it's going to be positive or negative, and then our highest power, so n, we call it the degree, or the highest power. Alright, so if our leading coefficient, again, is a number, if our leading coefficient is positive and our highest power is even, then we know that the graph is going to be going up as we go to the left on the graph, and the y values are going to be going up as we go to the right of the graph. That's the rule. If our leading coefficient is positive and our highest power is odd, then the y values are going to fall as we go to the left of the graph, and the y values will go up as we go to the right of the graph. If our leading coefficient is negative and our highest power is even, then the y values are going to fall as we go to the left of the graph, and the y values are going to fall as we go to the right of the graph. If our leading coefficient is negative and our highest power is odd, then the y values will go up as we go to the left of the graph, and our y values will go down as we go to the right of the graph. So what we want to do in example 12 is use these four rules and determine which graph matches each function without using technology. Because if we use technology and graph, this would be easy. Just y equals, graph it. Does it match? Yes. Does it not? Okay, no big deal. So what we want to do is practice using these rules. So first off, what we're going to do, so we say I'm going to do in green. We want to first figure out what a sub n is. Well, a sub n is our number in front of our highest power of x. So here, a sub n is 1. And obviously, that means a sub n is positive. Okay, so a sub n is greater than 0. And our highest power, n, is 3. Okay, well 3 is odd. Well, so since I know I'm positive and n is odd, I'm using this rule. So we know that the y values will fall as we go to the left of the graph. So we're looking for y values will fall as we go to the left of the graph. That could be either picture. Well, let's finish it off. The y values are going to go up as we go to the right of the graph. Y values are going up as we go to the right of the graph. So that means this is graph A. Well, by elimination, this has to be graph B, but let's check. I'm going to do part B in red. Again, our leading coefficient this time is a -1, so A sub n is -1, which means A sub n is negative. Also, our highest power is n equals 4, which is even. Okay, so I want to look for which rule to use. A sub n is negative and n is even. So this is the rule I'm using. So the y values fall as we go to the left of the graph. Y values fall as we go to the left of the graph. So that's working so far. Y values fall as we go to the right of the graph. Y values fall as we go to the right of the graph. That matches. So this is graph B. Okay? So end behavior is kind of a neat thing, but now that since they invented graphing calculators, it's kind of also an obsolete thing. So yeah, it's useful to understand the end behavior and understand the rules, but do you really need to memorize them? Maybe, maybe not. I'm not going to say definitely yes, memorize them, because we do have access to graphing calculators. Now, if you ever had a situation where you did not have access to a graphing calculator, this could help you a lot. So just keep that in mind. And as always, if you got questions, let me know. That's it for this video.